Okay, so K sigma level, what does that mean? It means that what is this? How many sigma levels that my process is, right? So we, as you know, in the Six Sigma, we want to have a Six Sigma process, right? But most of the cases, the processes are not Six Sigma, or Two Sigma, or One Sigma, or Three Sigma, right? How many Sigmas are your process? So that's what that K Sigma level is going to tell you, okay? So how to do that? You take the upper specification limits minus the lower specification limits divided by 2 times the standard deviations, because it's 1 standard deviation to the left and 1 standard deviation to the right, right? So you're gonna basically know how many standard deviations on average you have, okay? So it's 12.1 minus 11.9 divided by 2 times the standard deviation. That's 1.76. Means that this process is current at a 1.76 sigma level. And this is the same thing as your average sigma level, right? So we have 1.93 one side, 1.6 in the other, right? If you put that on average, like this plus this divided by 2, guess what? It's going to give me the 1.76, okay? Because you're divided by 2 standard deviations. Before we divide by 1, now we divide by 2. So you're just, summing them and divide by 2. That will be the same result, okay? But, let's stick to this formula, which is better. But people always complicate things, right? It's not as easy as it looks. And what people in Motorola and GE, that was kind of the founding fathers of the Six Sigma, as you can say, they realized that there's something called the process shift, okay? What does that mean? Well, let's say you collected some data and your process is 2 sigma levels, right? So you collected data and say, okay, I can see that I have 2 standard deviations one side, 2 standard deviations to the other side. Let's say tomorrow you collect data again. Is that going to be 2 sigma again? And maybe a month from now you collect the data again, and maybe 3 weeks after 3 weeks, after another month, and every 2 weeks, and you're collecting data. What's going to happen with your sample? Is that going to be the same every time? No, it's not. Every time that you collect data, it's going to be a little bit different, because your process the distribution will go to the right or to the left. It will have some kind of shift that it is going to do. Right, the same thing of rolling the dice. If I roll the dice 20 times now, and then I roll the dice again 20 times, and then again 20 times, and then again 20 times, and I compare those distributions, they're not going to be exactly the same, right? They're going to be a little different than each other. So that's the process shift. There's something that's going to be happening that every time your sample is not going to be exactly the same, okay? And that's what this thing is showing, right? So although you have a target here in the middle, and your process is perfect at 3 sigma level here to the right and to the left, okay? You're exactly mean centered, right? You're at 3 sigma level. When you start producing, and after some time passed by, there's going to be some shifts to the right and to the left. And what actually, how much it will be that shift is about 1.5 standard deviation, and that's empirical data, and that's a number that everybody kind of goes with it and don't discuss, right? Based on empirical data, based on studies made by GE and Motorola, we're going to use that. You don't want to get into that discussion, right? So it's going to shift 1.5 to the left and to the right, and let's consider that when you're looking at our sigma level. So what does that mean in practice? It means that, okay, let's say that we have a process, okay, and it is a 4.5 sigma level process, right? So a 4.5 sigma level process should generate 3.4 defects per million opportunity, and that's the scale that the Six Sigma uses, defects per million opportunity. So it's not defect percentage, it's not a percentage of defects, is a defect per million opportunity. And we're gonna have some discussions in class about why go so in depth and have a kind of a bigger number. Let's accept that for now and say, okay, we're in a 4.5 sigma level. I'm going to tell our customers that, okay, this is our process. It's very, very good. And our customer is going to say, no, you're not doing 3.4 defects per million opportunity. If you are in a 4.5 sigma level, which is here, you're always going to have a 1.5 shift. So because of the shift, because it goes left and to the right, when it goes to the left and to the right, it creates more defects, right? So it goes to the left, your specification limits are the same, so if your process going to this side and this side, is generating more defects. So if you apply this table with a 1.5 shift, it's actually going to generate 1,350 defects per million opportunity, which means the same thing as your 4.5 is actually being a 3 sigma level process, right? So when you want to have a 6 sigma process, you're actually going to generate 3.4 defects per million opportunities. So newsflash, having a 6 sigma process means that you actually have a 4.5 sigma process because of the shift. I see, I know, it is mind-blowing, but yeah, it did that with me as well when I found that out. And that's what the project shift is all about, right? So you're basically saying that your process is worse than that, and worse than it is by 1.5 1.5 sigmas, because of the variation that will occur during the past of time. And just for us to understand, what is the impact of being 2 or 3 or 4 or 5 sigma or 6 sigma level, right? So think about, you have a shop floor there that is working 200 times per year, and you expect a change back anytime that's incorrect. It is a defect, right? So if you're doing the same thing 200 times per year, if you're a 2 sigma level, okay, you're getting it wrong 62 times per year, right? Which is basically a lot, right? So it's a big percentage that is outside. If you have a 3 sigma level process, you're doing a wrong change about 13 times per year. Okay? If you're a 4 sigma, you're doing once a year. Okay, now that's a good process. If you're 5 sigma level, you're doing one thing wrong every 25 years. And if you become a 6 sigma process, if you're doing something wrong, change it wrong every 1,471 years. So that's the power of getting into 6 sigma, is that if you increase your sigma level, the number of defects that you're generating are going to reduce drastically. That's why we're using all those tools, and we're learning all this methodology, and we watching all those videos and doing those cool exams and learning all those tools.